This is Mr. Hannon. Welcome to What the Format. Today we're going to talk about function notation. Um, if you look right here, this is an equation, y equals 3x minus 7. So if you have more than one variable, you're going to set up the equation with one variable typically on one side, the other with the other numbers on the other side. Now, of course, that's not always the way it goes. They can move things around, but it helps it. It's easier to see equation notation, y equals. You could have t equals, v equals. Variables don't really matter, but function notation that changes from a variable to your function notation, f of x, and that's how this is read. This is read f of x, okay? That would be g of x. That would be h of x, all right? These are now called function rules, and one of the reasons they do this is so that they can handle multiple different functions in the same problem. A little hard to do that if you got y equals y equals y equals. Now all of a sudden you're like, wait, y is the same, so you're thinking the equations are the same. They may not necessarily be the same. So they came up with function notation. Also, it makes it easier for evaluating functions. Right here, f of 0, what do they mean? Well, they just want you to plug 0 in for x. So then that's just 2 times 0 plus 4, which is 0 plus 4, which is 4. So f of 0 is 4. If I plug 2 in there, 2 times 2, 4. 4 plus 4, 8. Okay, negative 3. Well, 2 times negative 3 is negative 6. So maybe with that one, I might want to write it out. This one was easier to see in my head. This one, not so much. Who makes that decision? Well, you do. Okay, some of these equations or function rules can get rather complex. Others are fairly simple. If you can see the math in your head and you can double check it and know you did it right, that's up to you. However, there are certain situations where writing it down is preferable because you can check yourself to make sure you don't make a mistake. So this is going to be negative 6 plus 4, which is then negative 2. Okay, notice all the integer math. Now, of course, these function rules could also have fractions in them or decimals. So really what we're dealing with here is 5th grade math, but the notation makes it look different, makes it look harder than it is. But once you know you're just plugging that number in, now be careful with this one, the negative x squared. A lot of students know that x squared turns you positive, which it does, but when you multiply by negative, you're going to go back to negative. So that's probably one I want to write out too. So I've got negative 2 squared minus 6. Well, negative 2 squared is 4, but then it's negative 4 minus 6, which is negative 10. Okay? Because see, yes, the negative 2 squared is positive, but when you multiply it by negative in front, it's going to go back to negative. 4 squared, well, 4 squared is 16, but then that's going to be negative 16 minus 6, which is negative 22. Okay? Plug in 10. Well, 10 squared is 100. So now that's going to be negative 100 minus 6, which is negative 106. All right. So on these, I'll leave those for you to try on your own. Okay? They can notice that the variables can change. You could have f, g, h. You have k of x, l of x, m of x, n of x, t of x. In physics, they like to use s of t, v of t, a of t. So even the variable sometimes will change instead of x, but that's function notation. Basically, you just plug it in and do the math. But now you can see how important your math facts and your math skills are. If you're having trouble with multiplication or division or addition or subtraction, especially with positive and negatives, that's something you would need to work on because function notation uses that a lot. And if you can't do it, then it makes these problems not only longer, but much more complicated. And you don't always have a calculator available to you. So anyway, hopefully this explained function notation and how to evaluate functions given this specific notation. This has been Mr. Hanna with What the Format. Happy mathing.